Welcome to my YouTube channel. In this video, I will show you different past years national examination problems on infinite series. So here, before I proceed to the problem solving, I will tell you one definition regarding infinite series. So here, let this an be a sequence and Sn be the n's partial sum, such that when n is getting bigger and bigger, this partial sum will go to a certain real number. It has to approach to a certain real number. So in this case, we will have the sum of the infinite series, which is convergent. Otherwise, the sequence or the series is divergent, right? So in our discussion, most of the problems are convergent infinite series. So in our discussion throughout my presentation, you may see this kind of notation. This is called sigma notation. That means a shorthand representation of this kind of expression. Rather than writing a plus 1 plus 2, a plus 2, a plus 3, and so on, we will use this sigma notation in the summation, okay? So what is the sum of the series? What is the sum of this series? Here, this series can be written as the series, the sum n starting from 1 up to infinity to the power of 2 times 3 to the power of 2 minus n. This can be written as 2 to the power of 2 can be taken out from the summation using the property of summation. So the inside term will be 3 to the power of 2 minus n. Now substitute n to the power of 2 is 4. 4 into 4n is equals to 1. This becomes 3 to the power of 2 minus 1. Whenever n is 2, 3 to the power of 2 minus 2. For n 3, 3 to the power of 2 minus 3. 3 minus 2 to the power of 4, and so on. This is infinite. So this can be written as 4 into 3 to the power of 1 plus 3 to the power of 2 minus 2 is 0. 3 to the power of 0 is 1. Then this one is 3 to the power of minus 1, 3 to the power of minus 2, and so on. Okay, this is infinite geometric series. Look, the ratio between here, the ratio between the second and the first is 1 over 3. Between the third and the second is 1 over 3, and so on. Therefore, this can be written as 4 into the first term over 1 minus the common ratio. Here I want to tell you one formula. The sum of infinite geometric series is given by G1 over 1 minus R, where this R is satisfying this condition. Okay, since the common ratio for this is 1 over 3, we will have this kind of result. So to have a clear understanding on the sum of geometric series, please visit my previous video. So for now, this is 4 into 3 over 1 minus 3. 1 over 3 is 2 over 3. So this is 4 into 9 over 2. Okay, this becomes 18. So the sum of this infinite geometric series is 18. Therefore, our answer is B. The next problem is, what is the value of this sum? This is again infinite geometric series. So let me write the problem properly. So this problem is written as the sum of the series given by 2 to the power of n plus 5 to the power of n, 5 to the power of n over 10 to the power of n. We can write this thing as like this. This 10 to the power of n is common, therefore we can write 2 to the power of n over 10 to the power of n plus 5 to the power of n over 10 to the power of n. Again, this is also written as the sum of n starting from 1 up to infinity. This n is common. Okay, here n is common. Therefore, it's possible to write like this, 2 over 10, the whole n plus, here n is common, 5 over 10, the whole n. Okay, now again this can also be written as, here 2 over 10 means 1 over 5 the power of n plus 1 over 2 the power of n. 5 over 10 means 1 over 2. So using the property of summation, we can take separately the summation n starting from 1 up to infinity, 1 over 5 the power of n plus the summation n starting from 1 up to infinity, 1 over 2 the whole n. Now we can rewrite this thing as, when we see the first one, I can write this as, in one bracket, 1 over 5 plus 1 over 5 the whole square plus 1 over 5 the whole cube, and so on. This is infinite term. And when we take the second summation, this one, let's take in another bracket 1 over 2 plus 1 over 2 the whole square plus 1 over 2 the whole cube, and so on. In both cases, these two are infinite geometric series because the ratio of the consecutive terms is constant. Therefore, the first term over 1 minus r, here the first term over 1 minus r. So here the first term in this bracket, the first term is 1 over 5. Okay, this is the first term, 1 over 5 over 1 minus, the common ratio is dividing the second term to the first term. The common ratio is 1 over 5. Both the first term and the common ratio are the same for this series. Plus, in the second bracket, the first term is 1 over 2, and the common ratio, meaning that the ratio between the second and the first is 1 over 2. So the common ratio is 1 over 2. Now, this ratio, you can verify that this result is 1 over 4, and the whole, this result is 1. Okay, so 1 over 4 plus 1 is 1 over 4 plus 1 is 5 over 4. 5 over 4. So the sum of this infinite series is 5 over 4. So our answer will be C. The next problem is again another infinite series. Unfortunately, most of these problems are geometric in nature. So what is the sum of this infinite geometric series? The sum n starting from 0 up to infinity, 5, 2 over 3 the power of n. This can be written as 5 into the summation, and starting from 0 up to infinity, 2 over 3 the power of n, but n will start from 0, so let us do it. 5 into, whenever n is 0, 2 over 3, the power of 0 is 1. Whenever n is 1, it becomes 2 over 3. Okay. Whenever n is 2, it becomes 2 over 3, the whole square. Then 2 over 3, the whole cube, and so on. So, definitely this is infinite geometric series where the first term is 1. The first term is 1 over the common difference is the ratio of the consecutive terms, which is 2 over 3. I mean, here I'm using the sum of this infinite series is g1 by 1 minus r, where g1 is the first term and r is the common ratio. So this can be written as 5 into 1 over 3, which is 5 times 3. The result is 15. Therefore, the sum of this infinite geometric series is 15. Which of the following is the sum of this series? Okay, so here this is an alternating series with minus and plus. So let us see what it looks like. We are asked 5 minus 10 over 3 plus 20 over 9 minus 40 over 27 plus minus plus and so on. So here the first term is g1 is 5. The first term is 5, and the common ratio is the common ratio is dividing the second term by the first, which is minus 10 over 3 divided by 5, which is minus 2 over 3. Since the absolute value of this series is the absolute value of r is less than 1, this series is convergent and we can calculate the values. So we use, so let me put this as S infinity, where S infinity is the sum of the infinite geometric series, which is given by g1 over 1 minus r, where g1 is 5 and r is negative 2 over 3. So this becomes 5 over 1 plus 2 over 3. This result is 5 over 3. So this becomes 3 times 5 over 5, which is 3 itself. So the sum of this infinite series is 3. Therefore, our answer is C. What is the sum of this series? So, as usual, we need to rewrite the given infinite series in more appropriate ways. 3 to the power of n times 4 to the power of minus n can be written as 3 here, 3 to the power of n over 4 to the power of n using the property of exponential. This can also be written as 3 over 4 to the power of n. So when we write this explicitly, this can be written as 3 over 4 plus 3 over 4 the whole square plus 3 over 4 the whole cube, and so on. This is infinite geometric series where the first term is 3 over 4 and the common ratio is can be obtained by dividing the second term to the first. Again, the common ratio is also 3 over 4. Therefore, the sum of this infinite series is g1 over 1 minus r, which is 3 over 4 over 1 minus 3 over 4. This is the same as 3 over 4 over 1 over 4. So this is 3 over 4 times 4 over 1, which is 3. Therefore, the sum of this infinite series is also 3. The other problem is, what is the sum of this series? Okay, to calculate the sum of this series, let us rewrite this thing. N starts from 1, then to the power of 2n plus 1 over 5 to the power of n minus 1 can be written as the sum of 2 to the power of 2n times 2 to the power of 1, which is 2, over 5 to the power of n times 5 to the power of minus 1. So this is the same as the sum of n starting from 1 up to infinity, 10 times 2 to the power of 2n over 5 to the power of n. Still, we need to rewrite this thing as 10 into the summation n starting from 1 up to infinity, 4 to the power of n over 5 to the power of n. So the last simplified form for this summation can be written as 10 into 4 over 5 to the power of n. So this can be written as 10 into 4 over 5 plus 4 over 5 over, the whole square, plus 4 over 5 the whole cube, and so on. Definitely this is infinite geometric series where the first term is 4 over 5 and the common ratio is 4 over 5. So the first term over 1 minus the common ratio means 10 into 4 over 5 over 1 over 5. Okay, so this can be written as 10 into 4 over 5 times 5, which is 40. So the sum of this infinite series is 40.